hopefully. There we go. All right. So today we're starting to talk about polygon area. We're going to talk about parallelograms, triangles, and trapezoids today. So you may have done area problems in the past. You probably have, like in middle school or even elementary school, done a little bit of area stuff. So we're going to get a big refresher on that today. We're also going to take it a little step further and look at applying some right triangle trig to these problems. We won't go, completely crazy in that department, but you do need to remember this stuff, and it's a good way to reinforce that stuff that we learned in Chapter 9. So with that, let's go ahead and grab our notes. All right, and this seems a little bit out of focus. Maybe it's just me. Anyway. 11.3, first day of it is going to be area of triangles, parallelograms, and trapezoids. And that's off center. Oh well. Okay. So we've done a little bit in the past with areas of triangles, and maybe even a little bit with areas of parallelograms. Can anyone remember how we found area of a triangle? Remember the formula for that? Might have been a while. Yeah, Caleb, nice. Base times height divided by 2. So we'll start with triangles. Base times height divided by 2. Now, the only thing that seems to trip people up with areas in general, or areas of triangles, at least in parallelograms, is figuring out what's the base and what's the height. What constitutes a height? So if we're looking at a triangle here, we might determine that this is the base. And then if that is the base, then a height would be a line from the opposite corner. Remember when we talked about altitudes with special segments of triangles? An altitude is the height of the triangle. Okay. So sometimes it will look like that and the height will be inside the triangle. Sometimes you'll get a situation like this where you have a right triangle and this could be the height and this could be the base here. Or sometimes you'll get a triangle that looks like this, and even if this is the base, the height you would have to drop down outside the triangle. So there's a lot of different ways that this can look. Just like when we were talking about altitudes, the different ways that that looked on our triangle. But the thing that we have to remember, the base is perpendicular to the height. So the base and the height always, always, always meet up at a right angle. All right. So then in dealing with that, let's just do an example where we're given the base and the height and we have to figure out the area. So first example. We've got this triangle and we've got some labeled sides, 10, 12, 20, 5. Okay. So if I'm finding the area of this triangle, then my base and my height have to be perpendicular. The only thing that I see where there's any kind of perpendicular is between this and this. So this would be my height here, the 5, and this 20 here would be my base. And we know that area is base times height divided by 2. So in this case, 20 times 5 divided by 2, which is 100 divided by 2, which is 50. And that would be square units. If it doesn't say what the units are, you can just say square units. If it says it was inches, it would be square inches, etc. Just like we did with circle area last week. Okay, so that's kind of the most simple example there. Any questions so far on that one? Any numbers we're not sure where they came from or anything like that? Okay. Yeah, this is the easy part, right? So let's step it up a level. All right, so for this one, what if we had something like this, similar picture, but this side is 15, this one is 6, this one is 10, and this angle is 32 degrees. Huh, well now I don't have any particular height on this thing, do I? I know, right? So in this case, we got to use our right triangle trig, and we don't really see a right triangle yet. So what I'm going to do is I'm going to drop a height from an altitude from this corner across to the opposite side. So this would be my height, but I don't know what the height is yet. So we do need to use right triangle trig. So that's where I look at the angle that I have, that 32 degrees. And we know that this height is the opposite side. And then this side here, 10 of this little right triangle inside here is the hypotenuse that's across from that right angle. So if I have opposite and hypotenuse, what should I use sine, cosine, or tangent to find that height? Sine, exactly. And we know that sine is opposite over hypotenuse. So first step, we're going to use trig to find height. So we're going to set up sine of 32 is equal to opposite over hypotenuse. So h over 10. Then we multiply by 10 on both sides. And we get to put 10 sine of 32 into the calculator. And we get 5.299 for the height. When you get to this step, I would keep at least 3 decimal places. We're going to round at the end, but it's not going to be to a whole number. It's probably going to be to the nearest 10th or the nearest 100th at the end. So I would keep like 3 decimal places so that you don't end up with a rounding error in your final answer. Okay, so now we have the height. All right, so now we have the height. So now we can plug in base and height to the area formula. So in this case, then area would be the base is 15, the height was 5.299, or you could even plug in 10 sine 32 here if you want to be extra careful about rounding error. Divided by 2. So 15 times 5.299 divided by 2 gives us 39.7 if we're rounding to the nearest 10th, or 0.74 if you're rounding to the nearest 100th. Okay, so that's about as difficult as the triangle ones get. Any questions off of those so far? Okay, then the next one we've got on the docket is parallelograms, and those are almost just like triangles. All right, so for area of a parallelogram, well, a parallelogram is basically like if I were to divide it into two shapes here, we would get two triangles that are the same. So for a parallelogram, area is just base times height, just not divided by 2, because it's like having two triangles. So base times height, if this is the base, the height is still perpendicular to the base. So you might see the height represented like this. You might see the height represented like this. It really depends. You might see it drawn in the middle of the shape, perpendicular to both of the bases. That's totally fine. There's a lot of different ways you'll see that represented. But anyway, for a parallelogram, it is base times height. So you will likely see problems like this, where you have a parallelogram and this length here is 10, this length here is 20, and this one is 8 or something like that. And so we would need to identify the base and the height and then multiply the two things. So in this case, the only perpendicular thing I see here is this. So 8 and 20 would be my base and height. So my area would just be 8 times 20, which is 160 square units, and we're done. All right. With parallelograms, you could also see something similar to the one with the triangle here using right triangle trig. And I will show one of those at the end if we have a moment, or I will show it tomorrow. But this is mostly what you're going to see on your assignments today. Stuff where you just multiply the base and the height. Okay. And then the last shape that we're going to talk about today is area of a trapezoid. Okay. So if you remember when we talked about trapezoids in general, what they looked like, they look kind of like this. And they had bases. We had base 1 and we had base 2, right? And so for area of a trapezoid, parentheses, base 1 plus base 2 times the height divided by 2. So this kind of looks like our area of a triangle formula, base times height divided by 2, but instead you have to add the bases together, multiply by the height, and divide by 2. And the height is perpendicular to both of the bases because the bases are parallel, right? So that's what it's going to look like for us. Occasionally you'll get a trapezoid that looks like this, where these are already perpendicular to one of the sides, so that would be your height. But here we go for the trapezoid example. All right. So there's our trapezoid. Now we've got to identify our bases and our height and plug them in. So here's base 1. It doesn't matter which one's base 1 and which one's base 2 as long as you pick both of the bases, not either of these sides. And then our height is going to be 6. So we're plugging them into our area formula. Base 1 plus base 2 times the height divided by 2. Now, if you're doing this in a calculator, you do need to make sure that you put these in parentheses when you add them together. Or you can add them together first and do 14 plus 25. Well, that's 39, and then times 6 divided by 2. That's fine as well. And we should get, when we plug that into the calculator, 117 square units. Any questions from that one? Okay, so I'm gonna have you guys try some real quick, and then we're gonna be done and get our assignment and all that. As you notice, today's assignment is some IXL sections. They should go fairly quickly for you. Okay, so go ahead and try those two real quick, and I will work on getting the homework posted. I know we've only got like a minute or two left of class, but please stick around for a moment. Okay, well, we're about out of time here. So real quick on this one, hopefully we got them. We should have 7 times 10 divided by 2, which comes out to 35. So if you did that, or if that's what you got, you are correct. And then on this one, 8 plus 14 times 10 divided by 2, because here's our base 1, base 2, and the height. So 8 plus 14 times 10 divided by 2 gives you 110 square units. So if that's what you got, you are correct. Okay, so then moving into the homework real quick, I posted it. It is there. If you might have to refresh the page. That's third period. That would be why it's not there. There it is. We have 2 IXLs, area of parallelograms and triangles, and area of trapezoids. Okay, so at this point, if you have questions, you are free to stick around and ask them. If you are good to go, then you guys are free to enjoy the rest of your Monday.